everyone, and yeah, hopefully we will learn something about Terraform AWS modules, and the most important part on this slide is Q&A. I will try to present what is Terraform AWS modules, who am I, and what kind of things happening, but most interestingly is if you have any questions, my kind of duty today is to answer these questions, or at least give you a search query to Google, okay? So let's start. My name is Anton Babenko. I've been AWS community hero, and I've been doing quite a lot in the Terraform field since 2015, when I discovered this tool and decided to contribute and write a bunch of different open source projects, like Terraform AWS modules is one which I'm going to talk about today. Also, I have been developing different utilities like pre-commit-terraform, which is a collection of GitHub hooks or Git hooks to help you with having clean codes, updating documentation, check that code is still valid, and many, many other things which I've been adding there. And then it seems like people are using it, which is quite interesting, right? Also, I've been doing fun with serverless just because it was rather hard to do managing serverless resources on AWS using Terraform. And a lot of people, for bad reasons, decided to just skip the whole idea of doing this. And they say, like, no, Terraform is bad for serverless. And my kind of take was that, no, it's not bad for serverless. There are just not enough tooling around it. So that's what I've been doing in serverless.tf project. And also, I've been collecting information over many years and writing Terraform best practices. Well, I wrote them actually in 2018. But then 2 years ago, a guy from, I think, somewhere in South America reached out to me and say, like, hey, I want to translate it to other languages. And I thought, like, oh, cool, so somebody is actually reading them. And then this project was translated to more than 15 languages, like a lot of different languages, which people seem to read and take it seriously, which is quite cool. I also do, when COVID started, what else can I do? Of course, I started a newsletter with publishing information about Terraform weekly. Like every Wednesday, I publish what I find interesting, and I always try to present it something what is more sophisticated than getting started with Terraform. So you will never, ever find information about how to install Terraform, or what is Terraform, or why you should be using it. I just skip this kind of content because I think you can all Google. And then I figure out that it's a pretty cool idea to have every Friday live stream where I'm talking to different creators of different tools, review different Terraform-related projects, and do live coding. Live coding seems to be the easiest one for me because I don't have to prepare, and I just sit and do whatever I want, and I try to explain it. So a lot of people who are learning Terraform, they find it useful. So if you are new, I hope you will find something useful. And yeah, that's what I've been doing. So serverless.tf, as well as Terraform AWS project, is something what I'm going to talk about today. It is actually a collection of more than 50 modules, which we collectively kind of developed. We, I mean, community at large. I started many of them like myself, but then people contributed and provide new modules. But we really try to focus on the same experience. So if you start using one of this module, you will have the same expectations across all other modules. They're very kind of easy to connect together and following exactly the same principles which were described on Terraform best practices. If you are thinking about VPC or EKS, these modules were installed more than, I here put 200 million. This is something what I could find from public data source. There are a lot of forks. A lot of people take this for inspiration, which means they take source code, remove everything what is like my name, and then they sell it, literally sell it, which is very funny. Some companies say that this is not open source, and they fork this stuff, remove all of my kind of political messages. I'm Ukrainian myself, and they say that this is open source. Open source is not politic. Okay, have fun, but I'm not talking to these people anymore. They're from Russia. So this job was actually sponsored by many people. Here I have 43 sponsors, but in fact there were about 80 of them. Most of these people are just regular users who use this stuff, and they find it useful because this stuff which we are developing is actually not requiring you to do a lot of heavy lifting yourself. So what you need to do is that, like, you have two options. One is that you go to documentation, you read a lot of stuff, you try to understand what's written. Like, you need to know AWS, you need to understand how Terraform works internally, you need to read documentation about individual resources, data sources, architectural patterns, how to connect these things together. Or you can use something what we developed, which we call Terraform AWS modules, which are very small for the consumer to know about, but internally it's a lot of magic. If you want, you can always look into source code and try to understand what we are doing. So at the end of the day, there are pretty much two groups of people who discovered Terraform AWS modules and they just get stuff done, or people who are thinking that, oh my God, Terraform is so hard, and why it's so hard? Am I the only person on the planet who is doing this myself? Or sometimes people connect things which were not designed to be connected this way, and they struggle with it, and then they say, like, oh, Terraform is bad choice. No, it's not bad choice. Just pick a little bit high abstraction. You don't need to go so low level yet. So why developers like this stuff? First of all, as I said, it's really a very large community. Of course, I cannot count people, but it's more than several thousands of people who are using, like thousands of companies who are using this stuff, including, probably every second company who are using AWS here in the Bay Area, which is quite interesting because almost none of them sponsor me, which is also very funny. They say, like, oh, we consume your stuff, but it's open source, so we don't need to pay you anything. That's how open source reality works, so that you know. It's not always like so easy and like, oh, open source, just go and everything is paid. No, it's actually thousands of hours spent on this. So we also try to explain to users that a lot of stuff which we do makes sense only if it is shown as an example. So it's not like piece of code which you can find on GitHub, which you run yourself and you read through it and you try to understand what author thought. We always include working examples. And all of these examples are always executable right away without you spending any brain cycle to just understand how author thought me, or should I edit some file somehow, somewhere. No, never. It's always Terraform init, Terraform apply, Terraform destroy if you are happy. That's it. And also documentation is written by humans most of the time, which means that we try to include understanding, explanation what we thought or why we wrote it this way, instead of just assuming that who cares about documentation. No, documentation was one of the main factors why it became popular, especially at the very beginning, like 2017, when, I'm not an English speaker, as you can imagine, but any documentation with lots of spelling mistakes is much better than no documentation. That's what I can see this on example myself. Later, there were people who were like native English speakers, and they say, like, okay, I see that you are struggling with documentation, let me correct you. And pull request was completely red with like all corrections of like wording and spelling mistakes which I had. Of course, I added Grammarly since that, so it helped me with my spelling, but still, it's a long way to go. So pre-commit-terraform is also helping quite a lot with updating input and outputs, as well as including some information about dependencies, what kind of resources. It's actually quite funny to know that this automatically generated documentation is very good search engine food because people will be searching for some resources, and a lot of code will be shown to them because it's mentioned there. So Google obviously understands that this is text file, so it indexes it very well, and when people search for some resource, they find this piece of code even higher than like official documentation, because in official documentation it's mentioned once, but we mention it hundreds of times with connected links everywhere. So it's by default a good source of information for Google. And as I said, compatibility and patterns which we use across all modules is really essential, because we never wanted to have one module which is different from another one by many reasons. One of the reasons is that I'd like to think about all of this as identical as possible for me to manage. So we have similar, let's say, GitHub workflows, similar structure, similar naming conventions everywhere, so that we can always understand which module, like, what is happening. And we can look into the same file structure. It's really easy to understand for users where things are happening and what kind of assumption they have. As well as the result of very large community, we have week 0 support for all stable versions of Terraform or AWS provider, because we know that a lot of people are watching it, and in many cases it takes not like weeks for some projects, but it takes literally less than a few hours for people to find bugs, to complain about something, and they like it very much. Complain is one of the hobby of open source community. As I can tell you, it has been very stable. So this is just an indicator of that people are still using it, and yeah, more than 500,000 provisions per day across all modules. So what is the module scope for Terraform AWS module, which is quite important to understand, is that all modules which we have, they have 100% flexibility. So if we're talking about a module for, let's say, for VPC, we support all possible combinations which each resource can have, as well as everything what these resources output, we always output it as well. So it's like a lot of inputs and a lot of outputs from these modules, which means that a lot of cases and common use cases will be always covered, which is really important, because you never know what kind of use case will be from user X, and maybe user Y doesn't want it. We don't care. We support everything, and a lot of people say big thanks exactly for that. Because if you look into other competitors, or not competitors, but other projects out there, they very often support their own use case, or like some subset of cases where they think like, okay, I'm good if I support subset, and that's it. We support much more. So we also require a little maintenance, which means that all modules which we are writing, they don't include any fancy functionality which Terraform adds over the years, and we don't support something what does not make sense. For example, we never support any things which I believe will be deprecated, or something what we have a little bit even hesitation that it's well implemented. Because Terraform is always moving target. Every week, every release, there are breaking changes, even if it's patch version. Who cares about patch version? There are still breaking changes. If you want to know, Google 0.15.4. There are a lot of memes about 0.15.4 specifically, where a lot of situations are happening, and only if you have a lot of time, you can learn about them, or you can use open source project where we dedicate a lot of time to implement it. So we always focus on resource modules to wrap individual resources. If you want to make something bigger, like infrastructure modules, then, for example, you connect your CloudFront with S3, with Amazon Certificate Manager. and you can call it static website module. This will be your job to connect these three modules together in your way how you want it to be, specifically for your needs. We provide lowest level building blocks, which by itself can be significantly bigger than you anticipate. For example, S3 bucket is not one resource. It was never one resource. It's a lot of resources with a lot of magic. Feel free to check out the source code. It's several thousand lines of code. But when I talk to people, especially when I started this project, they always were, at least one guy in the audience was always saying, like, come on, S3 bucket is the easiest thing. Like, what can possibly go wrong? I will just use resource, and that's it. Then when there was an upgrade last year from version 3 to version 4, it suddenly became not one resource, but 12 resources. Good luck updating this one. And then there was roll forward, which means like, oh, it's not breaking change anymore. So again, a lot of these things will happen in provider version. If you don't have anything to do, of course, you can monitor change log like I do and implement it in the module. But a lot of people prefer to get job done, really. So if we look into Terraform AWS modules design principles, we always try to define concepts like what is actually the module unit. For example, in RDS, what do we have? We have an instance, we have option group, we have parameter group. Can we connect them in different ways? And we figure out that in some cases it makes sense to be used independently. Let's say you want to spin up just one database instance, but you want to reuse your existing option group or parameter group. And we try to support as many cases as possible. With Terraform being not a programming language is sometimes very hard. That's why we look into how this should be implemented from the architecture point of view, and we try to implement just best practices early on. So we always think about different ways of extending functionality. So if you are spinning up, as I said, a relational database instance, you may want to bring your own resource so that you want to bring your parameter group. It's not always possible, or it's not always supported because of different limitations in Terraform, to put it simple. But when we parameterize everything and expose all outputs, it becomes quite flexible for all cases. And we always allow users to parameterize everything, so we don't hard code anything what can be user specific, like instance size or encryption true false. No, it's totally up to user always. When we have this possibility exposed to the user, then user will be in charge of how they configure all of these providers' resources themselves. And we never ever use functionality which is going to be changing or which just totally wrong, like workspaces. Like, who use Terraform workspaces? Good, nobody's using. You should never use them. Why? Because there are a lot of misunderstanding between them. Like, there are different types of workspaces in open source, in Terraform Cloud, and in general, this keyword is misused everywhere. So it's better if you think about your infrastructure as code as being as descriptive as possible. It's okay to have multiple folders, multiple files, but don't try to obfuscate it by using workspaces. Same with overrides and provisioners and code generators. You can do a lot of this in Terraform, but you should not be doing it. It's not part of Terraform design. It was added into Terraform early on, like overrides, but it should not be used. And yeah, traits of good Terraform modules, I put them into this order because putting them as documentation and as examples is much more important than having tests just because you think that tests are important. No, actually, users are going to consume your stuff, so make sure that you include examples and documentation and so on. I have a little bit of time, so I need to hurry up a little bit, but we are almost there. So pre-commit git hooks is a project which is used in Terraform AWS modules. Here, this very small snippet of configuration file, which will automatically format Terraform code, which will validate code that it's actually valid, will update documentation, and will run tf-lint to do static code analysis. This minimum thing is essential for everyone to contribute so that we never ever talk about something what is invalid, for example, or something what violates our tf-lint checks, so that we always talk about just subject, like what does this code do, can we improve it somehow, can we extend it, and so on. What about testing? I know that a lot of people always, like at least it was before. Now it's not so often. I don't know why, but now less people are talking about infrastructure testing. But nevertheless, this post, which I post on LinkedIn, I guess 3 years ago, is still perfectly valid. And I prove this at least every half year or even more. Like recently, I committed some code which was not working, and I don't remember which module was it, but it took less than half hour for people to complain. Everybody upvoted, a couple people opened pull request, a couple other people approved this pull request, and it was all when I was away for like 1 hour. And then when I came back, I said, okay, this pull request is pretty good, so I merged this one and close another one, say thanks, that's it. That's how it works. So you don't really need to come up with artificial infrastructure testing use cases, because you will never imagine how people are using. Simple example, which I was using for many years, was which region you are talking about. So if you are using, if your account is opened after, let's say, 2015, or I don't remember, then you have this set of services, or this VPC is configured differently. If you're using region in Frankfurt, in Europe, you don't have V3. AWS API will be using V3 or V4, but in other region it's using V4, something like this. It was pretty stable, and I knew about this. But then last week I discovered that it also depends which region you are going to use. Not even which region, but when this region was added. So S3 bucket policy, or actually log, ELB logs delivery policy should be written differently based on which region you are using, which is insane. How can I even guess about this? So of course I always allow user to figure out this, and if it is common sense, then we put it into the module, and we hide this complexity for user, and for user it will be enable ELB log delivery equal true. Great. Then inside of our code, we do significantly more than just like one line. We do a lot of checks, a lot of like which region was it using. We have white list of regions and black list of regions, and we try to guess somehow. It's not really as simple in some cases, but again, for the user, for usability, it's important that we hide all of this complexity for them, and users are interacting with very small surface. So why not test for Terraform AWS modules? I always expect that contributors will be pretty much from everyone and from anywhere. I cannot expect people to come up with a decent test written in anything else than in HCL, or they even better should be self-generated somehow. There are different methods, but requiring people to write Go code is not something what I see practically happening. Very often these tests, even in many open source projects, we can see that tests are there, but nobody is actually paying attention to them because they're just happy pass somewhere. Do we have tests? Yeah, we have. Can we trust them? No, of course not, because they don't cover anything. Like in reality, they don't cover anything. But some people may say like, oh yeah, we need to update them. But who will update them? People who contribute some Terraform code. In most cases, I'm really happy that a person contribute decent Terraform code. That's great. I cannot imagine that anyone will be writing tests and updating them. So that's, and I also think that testing is for developers, not for consumers in first place. It's for us to guarantee that things are doing as we design them to do. So that's what we use examples for. We have examples for all features, which we execute quite frequently. Now we execute them in real environments, but we have some attempts to execute them in local stack so that we don't have to wait to provision real resources or even pay for them. Paying is not the biggest problem, but waiting for some resources to be created is often not so easy. And a lot of issues can be discovered by executing just static analysis. This is something what I'd like to emphasize is use tflint and Terraform validate will help you to discover a lot of things, like, I don't know, 80% of bugs can be discovered using those tools. When it comes to infrastructure testing done right, I think that, well, there is a command which is called Terraform test, but it's not working, but it's there, which is funny. But it doesn't work at all, so, but it's there, which is funny. I just said this. Right, I think that using open policy agent to execute assertion, so to create infrastructure on some local stack or real environments, and then running open policy agent to verify whether certain resources were created in certain configuration is a very good direction. Unfortunately, unfortunately, I still don't know any public company who is working in this direction. There are a couple companies who are doing this privately. When I talk to them, like, you do great stuff, will you open source? I think about 1 year ago, they said, yes, we will. I still don't see anything from them, so probably it will never be open source. But it's a good idea also to use local stack just because it's much, much quicker. And yeah, questions? I still have a few minutes, so I highly appreciate questions, as it says here.